Well, hello everyone. So I am Bill Wagner, and I'm responsible for the .NET Managed Languages docs. And welcome to today's .NET Languages and Runtime Community Stand-Up. Our host is Kathleen Dollard, and our featured guest is Rikki Gibson. He is on the C# compiler team and the C# LDM, and is here with us to talk about source generation and interceptors. So I'll let Kathleen introduce herself, and then let you start chatting with Rikki, and let's get going.
Yeah, I'm Kathleen Dollard, and I'm also a member of the LDM or Language Design team. LDM stands for Language Design Meeting, but we're actually a team. And I work on the 3 managed languages at Microsoft, a few other things like .NET Interactive and System Command Line. So I'm pretty busy, but I have a great time. And I am super excited that we have a guest and a half today. The second is a full guest, but not currently on camera. So Jared Parsons is going to help us out in the chat, just in case you ask somebody in chat. You might know that's who is behind our little. It'll be behind the Visual Studio author. And today we have Rikki Gibson, and Rikki is part of the LDM, ready to answer our questions on .NET Interceptors, Roslyn Interceptors, which is a brand new sort of research level feature. And Rikki, I thought we'd start out by asking what interceptors are.
Sure. So, I mean, we could maybe pop up the screen share briefly,
Sure.
but the concept here is that you've got some ordinary code. You're calling methods and so on, and you'd like to be able to do some kind of specialization of a call, right? So this is sort of a very clean room kind of example, but pretty much you can add additional declarations later on in the compilation, like in new files and so on, and those new declarations are able to reference specific call sites. So like over here, I've got an ordinary call to some method, which binds to this. It refers to this method, and then I've got an attribute that refers to the location of a particular call somewhere else. And it basically is like an instrumentation feature that says like, hey, call this one instead. So it allows for a limited form of substitution to occur.
All right. So I in code that I write, I'm saying call X, and X reroutes to something else behind the scenes without me having to worry about it. So that sounds awesome. But I guess I kind of wind up with a question of like, where am I going to use this? What are the use cases where this is valuable? And also a little bit questions we'll come back to about like, how's this safe? But let's start out with where is this useful to us?
Sure. So one of the key scenarios we're thinking about with this is ASP.NET Minimal API, especially in interaction with some of the newer runtime features we're looking at. So when you use Minimal API, you call app map get or something like that, you provide a route, you provide a handler. The framework is going to generate a thunk under the hood, and that's going to handle, the sort of raw content of the HTTP request and response. Is going to, map those to the strongly typed parameters that you've provided in your handler, and it's going to wire everything up so that your handler just gets called with what you expect, right?
Yeah.
And the way that's worked to date is by runtime code generation, which does add a little bit to startup time. But what's really compelling about this area for us is that when we're looking at native AOT, which we really want to get out to more people in order to, improve startup time further, reduce memory usage and deployment size and everything like that, we want to make it so that this sort of substitution can happen at compile time. And yeah, so basically we're looking at intercepting calls like this map get, so that after your code is built, instead of calling this sort of single central map get that comes from the library, it actually gets substituted with a specialized map get that's just for this call, that's just for wiring things into your handler.
Okay, so first, can you up the font size on both this and the code when you get back to it? That would be super awesome. And then so getting back to what you just said is the reason we want to do this in this case, and probably in many cases, I guess, for interceptors, is we had something which we could do like with an emit and or maybe reflection or something like that, but we had a way we could do the job. But now we can effectively hard code the exact routing into the call, because it's hard coded into this alternate location, which we're going to point over to. Is that pretty much the story?
Yeah, I think so. I'm sorry, I saw a chat message come in.
Yeah, that's okay. I was putting that. It's kind of on point in that.
Yeah.
So the essential power of this feature is that it lets you specialize a call based on the context of what's occurring, right? So another sort of mainline scenario that we might be looking at is like regex. If you say regex.match, you pass a constant string. We've already got a feature that lets you declare a partial method with an attribute that says, generate a regex, right? And now we'd be looking at a feature where you don't have to separately declare a method. You can just kind of pass a pattern string in, and at compile time, we're going to generate an awesome regex matcher for you. So it has a way of sort of streamlining some of the existing use cases for source generators.
Okay, so for regex right now, we have to put a attribute on it to give a little bit more information, and we just wouldn't have to do that anymore. We could just directly, we could just use like a regex string, and just all of a sudden magic, it would happen. We wouldn't change the code, and all of a sudden we'd get that new regex magic that does the partial class, the partial method that makes things go so fast, correct? Or is
that's
okay.
Right.
Okay, cool. That's awesome. Okay, so this is dependent on source generation, you said. So can you maybe go back to the original code and show us why we need a source generator and what it's doing to help us here?
Yeah, and that one we definitely need to zoom in a bit.
Yeah, we lost my zoom. Here we go.
That's okay.
How are we doing now?
That's definitely readable. Thanks, Rikki.
Gibbon wants to leave that on the side, but we'll live with it. Basically, a source generator is pretty much it's a .NET library that gets loaded into the compiler, and it can add source files to your compilation, right? So you can write one of these libraries and examine the state of the build and sort of determine whatever information you want and add additional types and methods and so on to your compilation during the build. And this is a feature that we anticipate to be heavily or even exclusively used by source generators because it's so dependent on source positions, right? This is actually, let's look at a better example over here, I think. This sort of abstracts it out, but you might imagine like one indexed line and column numbers, like, maybe like line 5 in this file and, column like 3. We would insert these here, and basically this is very brittle to be writing in user code. This is not something you want to write in user code. So with a source generator, it's simply updated whenever you make edits, right? So that issue doesn't exist in the same way. But does that adequately explain kind of what a source generator is and how this relates?
Yeah. No, I think that's great. And another thing I'm noticing there, which I think is fantastic, is that the you have an interceptable attribute on the declaration of the method. So it looks like I have to opt in on my method and say my method can be intercepted and rerouted, and that without that, none of it, you can't do this without that.
Yeah, this is something that we're still playing with a bit. Like, there have been some concerns raised. Like, on the one hand, we want to have a decent level of traceability for this, and we have looked sort of very thoroughly at what this would mean all the way kind of down the stack and through the tooling and everything like that to make it clear to users that this is what's going on. And that's a challenge. But we were thinking that interceptable attribute might help with that, where if you F12 and you see like, oh, this has that attribute, maybe the calls are getting intercepted, right? We're also concerned about this question of sort of permission and ownership. So one of the cases we're thinking about is like EF Core. They may want to take your query expressions and at compile time, translate them into whatever SQL representation and sort of turn your call to the methods that realize your query into sort of lookups in a table of these pre-computed queries and that kind of stuff, right? And we're concerned that EF Core doesn't solely own iQueryable, right? And they need to be able to intercept those methods. So we may actually be removing this attribute from the design. But it's something that we're weighing. Sort of, it's a trade-off. But yeah, this is sort of the intent of the design at this moment in time, what we're showing.
Okay. So certainly if people have opinions on that, feel free to weigh in. I'm sure it's something you've thought more about than I have at this point. It feels comfortable to have it there because it feels comfortable to know that it's not just anything that could be intercepted, that it's the things that someone has opted into to say this is a logical place. There is a scenario for this to be intercepted. So yeah. Cool.
So I actually have a question, and if this takes us way off the rails, just ignore me. Okay. So you had an interesting scenario there with EF core. Now, could I write an interceptor that looked at a query expression, right, that maybe had new C# syntax that isn't expressible as an expression tree, but if I know how it's lowered, I can intercept it and change that to say it now looks like this, which is the lowered form that could be an expression tree. Not that
That's a really interesting question.
Yeah.
I think as designed, it's not going to be possible because the interceptor is still going to have a parameter with type expression of func whatever.
Okay.
And so all those same limitations on what expression trees can have will still be there. But that is kind of interesting. I'd be curious to look a little bit about how that intersects with some of our larger problems with expression trees and moving them forward.
So there are a few other ones that are. This one also may be kind of off topic on interceptors in general, but it was as you were talking about how that map get gets mapped in, and would the lambda in there be inlined as well, or does that end up in a different as a different kind of...
I guess the question is whether this lambda is it converted to delegate and then called inside the implementation of this, or is the implementation sort of recreated inside this specialized map get? And I would probably expect that the lambda just gets called, but the folks on the ASP.NET side are probably going to have some latitude to play with things in that case. Probably one of the main challenges with that is that if you were to try and sort of inline this lambda in a sense, you would have to do a bunch of line directive stuff to make it so debugging this still works. Hopefully I interpreted the question correctly.
I think so. And then one of the other questions kind of on the design is, does the parameter, I don't know if you mean type or value, so we may as well answer both. Does the parameter need to be known at compile time?
Yeah, so this is a major sort of constraint on this approach, which is that if this route, I think maybe the route can be variable, but I think probably the signature of this handler, we need to know sort of how to create this thunk completely at compile time, which means that we need to know kind of everything about its signature at compile time. And that means that you wouldn't be able to like convert to system.delegate and pass it in. I think we probably wouldn't do interception here if the argument were not simply a lambda expression or like a usage of like a method group, for example, right? Something that we can directly link back to, like, okay, here's the parameter names, here's how we get everything out of the query string, and so on, right? And same with regex, right? If you used a non-constant pattern, we would fall back to the non-specialized implementation, and that's sort of how we're somewhat inclined to see this, is like when we can specialize for you and make it nicer because you're passing certain constants, then we do so. And if we can't, then we fall back to sort of a non-specialized general path.
Okay. And then we had one other question that's pretty relevant to where the discussion is now is, Tal asks, how is this different from the F# inline if lambda?
I don't think I'm actually familiar with that, so it's difficult for me to comment. I'd be curious to know.
Okay, so we may let Jared answer that one in the chat, unless you know, Kathleen.
I'm not sure, but I think I know. I think it's the fact that the routing is determined. I didn't think that happened with an F# inline lambda. I thought it just took the lambda and inlined what it had. I could be wrong about that because I haven't used that feature much. But I think that the key thing here is that you're writing your code with a particular signature, and that signature during, before source generation has some sort of a body. but that body is fully replaced by the body of the place that we're routing to, of the what, I don't know what we call what do we call the thing, the new thing that's getting
The
generated?
interceptor?
Is that the that we call
the new thing that we
okay,
call
so
here is the interceptor, and the original method we call interceptable.
Interceptable. Okay, so the interceptor can completely replace the code and do something quite different. So you can imagine, the case of regex where we have to bust something apart with, to do nasty things without source generation involvement. And when we have source generators, we don't have to do that. Now, I do have a question. So it sounds to me, Rikki, like this does result in a system, and I'm thinking of, I guess I'm thinking about regex right now. It seems like we risk falling into a situation where a very small change to your code can affect your trimmability completely. So trimming, for those of you who don't know what we mean when we say that, this is the ability to do AOT trimming and wind up with smaller DLLs in the end. Is that true? Are we vulnerable now to fairly small changes? I use a variable instead of a constant for a regex expression, and then I wind up using reflection. I think that's what regex used to use, or maybe it was something different.
That would be like what regex uses in native AOT when you're not specializing. I think that it might be. It depends on a lot. But this is definitely a little bit of a risk. That when you move away from constants, you will start using the original symbol when maybe you weren't before, and so you have to sort of monitor the size of your app, monitor those deltas. Okay,
that's fine. I mean, that's what we have. That's what we have CI for, and we can look and see if there's more telemetry we want about that. So, Bill, do you have any other questions yourself or from chat?
Yeah, I don't have a lot of really good ones right now in chat. I'll keep watching that. But I had one that's kind of related to the discussion you just had. Is on the flip side now, if we're doing this intercepting and source generation and we're avoiding some of the reflection, shouldn't that help us in the AOT scenario of being able to trim better? Because if we know there's no reflection APIs, you are more likely to have a closed set of the APIs you're using, right?
Yeah, native AOT and trimming is hugely related to our motivation here. I mean, the most compelling of all is sort of letting you use things at all, specifically when things depend on runtime code generation, which is what you can't do in native AOT is runtime code generation. And then avoiding reflection, of course, lets you trim much better. And the particular way this works, we've weighed a bunch of possible ways to solve this. And part of what has pushed us toward this specific approach is that emphasis on trimmability, right? Some of the sort of prototypes that we were playing with were kind of involving like little dispatch blocks that would sort of take caller line number, caller file path and stuff like that. And they would actually like switch on them, essentially, like look up in a dictionary or something. But that means that you're sort of referencing the whole graph of everything that calls mapget, for example, right? And it makes it more difficult to trim that when there are actually dead code paths elsewhere. So native AOT is very, very key to what's motivating us here.
And this is good. It gave us two good new questions. One right now that probably all three of us can answer a little bit is, why do we care? And, we didn't care about AOT, 20 years ago. Why do we care now?
Sure. So basically, cloud hosting environment stuff, right? So there's a lot of benefit to being able to start up really fast. Cloud hosting wants to be able to sort of spin up and spin down your app when it's in use or not, and we want to be able to reduce memory usage so we can run more apps on the same box, stuff like that. All of that, has the effect of reducing cost, meaningfully, and increasing responsiveness and so on.
Yeah, and then to add a few things is I know that some of the cloud providers and big cloud users are now measuring costs in watts per user. So that that kind of thing plays into, you know, how many boxes do I need and so on. And, you know, we all have that, you know, on our phone apps, right? The less work it has to do to start up and get going, and by not jitting on your phone, you know, that helps battery life in a lot of scenarios as well. So I think there are a lot of reasons as we look at different form factors where that suddenly becomes more interesting. Another one that is sort of a question in the form of a comment, but I think it's worth addressing, both in terms of source generators and in terms of interceptors, is I don't know if this is cool. Let's hope it doesn't become a cancer. It reminds me of FODI, misuse potential. What's that?
Rikki and I could talk. I said, "Oh boy, Rikki and I could probably talk quite a bit about this, because yes, this is, you know, it's we had this. Rikki, I'm going to just answer one part of this. Okay, rather this progression. Okay, it's kind of analyzers. It's a bit hard to misuse. Okay, and then we have source generators, and you can definitely misuse them, overuse them, and cause performance problems in Visual Studio. And then we have interceptors, and we actually think that they are. I don't know. We need to make sure we have our story straight. We need to make sure we understand a lot of things. I want to be really clear. This is an experimental feature right now. And there is a high probability that it will go out as an experimental feature that we're using internally, but we can change. And we don't like asking our customers to change. So at the present, we cannot say that this is going to go out in .NET 8 as a full feature. It is quite likely to go out as an experimental feature. And one of the reasons is that we've created some performance problems with source generators, and we don't want to increase with interceptors. Rikki, please add to that.
I would love to comment on that.
So
the first thing I want to say about this is that we are very, very deliberately trying to give ourselves space to get this wrong and learn from it and come up with something that's better. We are somewhat thinking of this as like a almost tactical approach to get more information out of some usage and enable our partners to ship some really valuable sort of dev experiences for .NET 8, hopefully. We've looked at this area a ton of different ways. Like I've looked at this problem of specializing calls, you know, with the sort of dispatch block approach. We've revisited like the source generator replace original concept. And I do want to say that like I haven't spent a ton of hours working with like aspect-oriented programming, right? And I can understand how there could be challenges in like living with having a lot of that in your project, in your world, toolability and so on. I'm not familiar with the details in .NET, but I do have a sense that there's a lot of productivity that can come from having these kinds of things. And this feels like almost dipping a toe in the water of something that's like adjacent to that. And we almost want to see like how much does the world unravel when we start experimenting with this. I'm personally really interested in seeing how and whether we could come up with something that's sort of more general and more appropriate to what like aspect-oriented programmers might actually kind of want from us. One concern that we have with the current design is that it lacks composability, right? So when you intercept a method call, you only get to replace it once. You don't get to say like this component replaces it to add logging, and this next one replaces it to add something else, and so on, which is sort of what aspect-oriented would allow you to do. And that's something that we've been struggling with on a more broad level with source generators, right? The fact that source generators can't see each other's outputs, right? But it's something that I'm determined to continue wrestling with to try and help us land in a good place in the long haul, right? Hopefully that helps clarify our position here. And I also do want to comment that like this concept of referring to source locations, line and column numbers of calls, there's a like instinctive ick factor to that, right? And we might as well acknowledge that. We've definitely played with other ways of identifying and specializing specific calls, right? A lot of languages would probably do what we're doing with like a macro system, right? In Rust, you might say like map get bang, and it replaces it with something. I'm actually not familiar with whether any web frameworks in Rust, for example, do that. But that's the sort of area that we're in, and we saw at least from our perspective right now, we saw this kind of an approach that's driven by source generators as much less expensive and risky for .NET compared to adding like a macro system and deciding what that would mean and deciding what they can do, right? It's almost like source generators are our macro authoring system in a little way, and this is something that should make people like a little bit like skeptical, right? Because macros can be really wild, but we're determined to try and bring that power in without destroying your ability to understand your code and tool it and everything like that.
Yeah, and I'll, if I can add a little bit too from consuming these things, I find there's a few really interesting points, and then also as people are watching chat, Jared has been weighing in extensively on this issue as well in text. But I think it's when we talk about new features in the language, at times I often will use the term how is it lowered to something that's already there, right? So if we're trying to do something like the first scenario Rikki said with mapget, we could either add new interesting language keywords that tells the compiler how to generate all kinds of code at compile time, or have this other thing that looks at it and goes, oh, I can insert some and replace some code and make it better and faster. And then at that point, it becomes the compiler and then jitter AOT that generates what you actually execute. The parts that I think are really cool when done well, and a previous version of this with Stephen Tobe showed this with the regex source generator, is because it's generating C# code that then gets compiled, you can debug right into what the source generator's output is. And the same will be true here. You could debug right into what the interceptor writes for you and understand what it looks like. And a lot of work, especially went into the output from the source generators that the runtime team provides, so that it does really look like idiomatic C# code, and it's really easy to read and understand if you know C# to go, oh yeah, that's what it's doing. This is cool. And I think that's really an important part to get this started. And it to me, it just kind of feels like you're adding a layer on top of the language that, like Rikki said, it's kind of like our macro language, and there's a lot of things we can add there.
Yeah, I mean, I'm curious, to what extent, people in other languages have gotten into debugging the expansions of their macros and how much they've enjoyed that. It doesn't sound like the most fun thing in the world, but sometimes things will go wrong in like the generated code, for example. There might be a bug in the implementation, or it interacts with what you're doing in an unexpected way, and you need to understand what the state of things is. So it's been very difficult, but extremely important to us to provide that traceability, right, by showing you the generated source in the editor and letting you step through it and so on.
And I will say, having had to debug code with macros in C, I absolutely hated it.
Yeah. So, Rikki, would you say that we're on a journey here, and that interceptors are an interesting new step along a journey, or would you describe that in a different way?
I mean, I think that's a good way to describe it. This is definitely something we're doing to learn, and we're eager to see what comes from it. What kind of experience people end up having when they try out, ASP.NET Minimal API with native AOT and .NET 8, and that kind of stuff.
This does sort of get to one of the areas that Kathleen had promised early on that we should definitely touch on, is what are the security implications for an interceptor? I mean, instead of just adding code, you now might be removing stuff I wrote and putting something else in there that that feels dangerous.
Yeah. So this is something that early on we thought, okay, maybe we need an interceptable attribute so that we kind of limit the places that this can happen. But having examined it a bit, there is a sense that if an untrusted component is adding files to your build, it's game over. So it may be inserting an interceptor that changes which thing is being called somewhere, right? But it might also be adding like a module initializer that just does whatever when your app loads, right? And it's all over at that point. So this is, part of why some of our separate initiatives around like supply chain security are so important. But we think that interceptors don't introduce any distinct security issues.
That didn't make me feel better, but I think I understand.
Not really.
Yeah.
Not really. But it's realistic, and so that's good. Yeah, I really like the notion of the use that you're talking about for this. The whole feature is still kind of like whoa kind of feeling. It's not totally comfortable feeling, but the cases you're talking about, you're taking something and doing the exact same functionality, exactly what the user expected. You're just doing it better. You're doing it more trimmably. You're doing it faster. And so both the regex and the minimal API example are, I know what this code is doing. It's blah, blah, blah. And if I were to say the words, those words would probably fit both implementations, both the slower or the less performant one and the replaced one. And so that feels really fun. It feels like a controlled optimization at that point. And I love it when I think about it in that term. It's just a more easier to access. So again, since it's experiment, we'll mostly be doing inside Microsoft, that we have a capability to have this map get be optimized. And that's what it kind of feels like when you talk about it.
Yeah, that's what it is.
Okay.
All right. So do we have anything that Jared's not already answering in the chat, or anything he's answering that we want to go into further? I see this stuff on macros and stuff. I can't say the word macros without people starting to talk about macros. So for sure.
So this is an interesting one that kind of plays onto, can I opt in or out of this interceptor code? And I think it's also probably a good time to discuss what this means in terms of dynamic code, and that I don't think of interceptors as dynamic. So that might be part of how we answer this one as well.
Could we instead write our function with a static if this is known in compile time, run this code generation, else run the dynamic code? So this sounds a little bit like the dispatch block concept that we've also been looking at. And this would be like you literally like look at all the ways this method gets called. Any constant value that you might see propagating in through any flow process that the source generator might devise, make Alan Turing roll in his grave or something. But you'd have a default case that calls the non-specialized version. Basically, you'd say like, here's the values that I know might get passed in, and I'll specialize for them, and then I'll fall back, right?
Mm-hmm. And two other really good questions that have just been added. So is there a way to only allow interceptors from a specific assembly? In other words, regex's max could say only source gens from the BCL can intercept this.
Yeah, this is something that we considered a bit. It's something where we're not sure if we would want to put that limitation like into the BCL itself, for example, say like only assemblies with a certain name or certain public key token can do the interception, right? Sort of like how internals visible to works. We might want to put it sort of in the user's project and let them say like, hey, I'm doing something where I want to be able to intercept this. I know something about how I want this to be done. I can do it better. And we don't want to stop you from doing that, right? And so we're sort of in this balancing act of like, we want to prevent unexpected or sort of more air quotes dangerous interceptions from occurring, but we still don't want to tie our hands as well, right?
So that kind of as a follow-up, and then we have a couple other good questions. I assume interception was just inside a single assembly.
Yeah, so when we're trying to intercept calls, only a call which is occurring in the currently compiling source can be intercepted, right? So when you've got an external library, it's not possible to like reach into that library and then modify like which methods get called in certain places. It's only in your source code.
Right. So it is basically modifying the output of this compilation.
Yeah. And additionally, the call which is intercepted as well as the interceptor have to be in the same compilation.
Okay. So
you can't have a library that has an interceptable attribute that happens to refer to your file path line column, and then like when you compile, we like reach into that library over there and realize we're supposed to call that there instead, kind of thing.
And then Jared has added some comments on this, but I think it's probably worth bringing forward as well. Jason Bach has had a question and kind of a follow-up on here as well. So it seems like it's an opt-in and that I have to specify if it can be interceptable. And then, as a follow-up, but then getting specific interceptors, it's just not clicking. I'm not sure. Do we have something like a soup to nuts demo, or can we even kind of walk through one scenario? Like what would I write and what would I see happen to use an interceptor?
Sure. So, I mean, you would just, as a user of interceptors, you would just write your code the way that you ordinarily write it. But in a source generator, you would do something like, hold on, let me see if I can pull something useful up here. So like this is one of our little experiments that we've been playing with related to this. So this this happens to have a map get call, and then don't recall if we committed this. It's probably this one.
And then I'm just going to take the comment off screen to give us a little more real estate. But
yeah, and then the interceptor that we generated, please give me some space. The interceptor that we generate in this case, looks kind of like this. The name of the interceptor doesn't need to match the original method, but it does have like a file path and a line column. Let's see. And yeah, this does a bunch of thunk stuff. Hopefully that gives a little bit of a sense of like the kind of implementation stuff that we're hiding.
Yeah, Rikki, the other thing I think might help here is let me walk through this and see if I've got this right. Okay, so we have map-get that's defined in a library, okay, and it has an interceptable attribute on it sitting out in a library. That library also has a source generator, and my code has a reference to that library, both its source generator and the map-get method with the interceptable attribute. So my code simply says map-get blah, whatever I need to do there. And then during the compilation of my code, my project, then it's going to, since it accesses that references that library, it's going to run that source generator. That source generator is going to add more code to my compilation, and I'm going to be able to see that later, so that we have extra code sitting right there because of that source generator. And part of that generated code is going to be this interceptor, which then the runtime is going to route through. I don't know if it doesn't change. Is it just the runtime routes through to that new interceptor?
I mean, the compiler is going to adjust CodeGen to decide to call the new thing.
Right.
But yeah, we would add a file kind of like this one with using a source generator.
Okay, cool. So I guess, Jason, I'm wondering if that helped. And if not, maybe we could get some more specific questions around this, because I do think that maybe one of the most useful things we can do right now is to try to get this big picture to be something that that makes sense to folks.
So if I can sort of summarize, it sounds like I would write something more or less normal, and an interceptor would go, aha, you're doing this at line 12. So instead of the call you made, I'm going to inject some other code here and have you call this thing my source generator output. And then that's what actually executes.
Yeah.
And it should be semantically similar or semantically identical to what I wrote.
It's actually syntactically, what I write is absolutely identical. I don't even necessarily know this is going on, and I can apply this to existing code. Is that true or not?
That's true.
Okay.
Basically, we'd expect that you'd be able to write like a minimal API app that's like non-native AOT, for example, that doesn't use this source generator, and then you change a property and like you add a source generator that starts adding these specializations, and your code doesn't change one bit. But
Okay,
we
super.
do substitute out some of these calls for specialized implementations.
Okay, cool. All right.
So, and
Okay.
kind of a related one as we're going through this big scenario, and then there's a few other good ones that have just come in. So we've got, what if I have two interceptors that are both supposed to change the same thing?
Yeah, so the design now is a compile time error. And this is something that I'm very curious about what we can do here, because it's hearkening to like, I want to be able to specialize the same thing in multiple ways. Multiple components are doing something here. It's like it's a composition question, right? And for now, it's similar to our story with search generators, that you sort of like partial method implementations, even, for example, right? You only get to implement it once. You only get to substitute it once. If you do it twice, we don't know what to use, which one to use, right? But that when we look at this area more broadly, I'm personally very curious about, what designs may exist that would allow that kind of thing, and allow sort of a greater kind of generality, right? The ability to sort of handle multiple cross-cutting concerns independently.
Okay. And then Jason did respond, and I'll probably take this for me at some point in the future, as it kind of helps. But suppose, for an example, we just said, hey, I've got this method, it does this, and now I put an interceptor in, and it does something. We have bits, I could probably do that.
Yeah, I mean, I think this probably adds up to the kind of example we're looking for, which is that this is a call site right here, and then over here is the interceptor, and we just do a little switcheroo so that this gets called instead.
Yep.
Hopefully that helps.
A couple of other really good scenario questions here is we have this one. So, what if I want to start writing unit tests with aspect-oriented program? Could I don't know if mock is the right word there, or maybe just generate my whole test projects. I add some attributes here. Can I have a source generator and interceptor just test everything, build all of it for me?
So I think folks have asked about mocking in the past, and if I'm understanding right, I think the main issue is that when you mock something, it's already been compiled, and you have some object with virtual methods or something like that, and you just throw in an implementation that has sort of stub implementations of those methods, right? Hard-coded implementations or something. And Interceptors doesn't really help you with that, at least if you've already compiled the thing that you're testing, right? Because everything's fixed at that point. This doesn't insert like an override of a method, or it's not particularly intended for that. So I think it probably won't help a lot with testing scenarios. Perhaps if you're like building things in an entirely new configuration where your test framework is actually inserting interceptors that have the effect of mocking, and you build again, then maybe something could happen there, but it's something I haven't thought about a whole lot.
And I think it's an interesting scenario, but it brings up a problem that perhaps our current, or at least a couple of problems that perhaps our current generation set does not cover. So we are pretty much doing a transient approach at the moment. And a lot of, maybe I think almost all historic generation, except AOP, has been a non-transient generation approach. So, we generate per compile, and you don't get to grab that code and make changes to it, or it can be challenging to augment and all. And so I think some of the things around generation, and we are doing work in this space, are better, are well suited to a more permanent generation approach, where we look at what you're doing, we create a test project for you, and then and looking at things in this space, and then you get to take control over that. And maybe there's things that say, oh, your tests don't make sense anymore, you're missing something, we can tell that you don't have something that you need to include in your coverage. But yeah, so it's a space we're thinking about, but it's quite orthogonal to this. It's actually even in different teams. to say, yes, we know that testing is too hard, and we know there's too much test without coverage. So we absolutely think that space is interesting, but I don't know that interceptors or source generators are really going to get us a lot of answers in that space.
And you kind of added SwiftCut added a bit of a follow up there.
Yeah.
Yeah.
That answers part
where
of
you're heading.
Yeah, that you would be recompiling and just adding these in order to modify what the implementation is doing, which is kind of it's an interesting concept. I'd be curious to look at it a little more deeply. I think I could picture it, but certainly when it comes to figuring out what each implementation is doing, making that so that's hand authorizable, right? You would probably need to start looking at like your generation framework creates partial method what do you call them, definitions, and then user provides the implementations, for example, right? So that you can manage those line column numbers. You don't want to be writing those.
Yeah. It's very much. I think it's a very rich space for us to do more for auxiliary things, and I also think we don't want to forget that we can generate things other than just code. So even something as simple as using Roslyn to create a text file of your API, and then have an approvals test of that, so you always know if you have a regression. So there's different things that we can do, but some of those are like permanent artifacts that you want to check in, and some of those, which is the non-transient, to me, that's, are you going to check it in? Okay, and so we have that sort of permanence that we want on certain things, and those things Roslyn generation is not suited for at present. And then we have things that we want to have this compilation, which is the full focus. This compilation is the full focus. Now you point out that we could have a switch, and I have to say that it's uncomfortable to me to say that we would have two different compilations that are vastly different. One's mocked and one's not, based on a switch, because that says we could do other vastly different things based on a switch. And that, it's just uncomfortable to me right now. I don't know. Maybe it's a great idea, but I don't jump to being comfortable with it.
Okay. And then after finishing that one, we have this one. Did you find a good solution to the line column specification and different line endings? Some also, commit source generator output to the, could somebody commit the output to the generator accidentally? And I'll also just add, before you answer, we've got about little under 15 minutes left. So if you have other questions, definitely please add them to chat. So there we go. So what are we doing here?
So line column specification and line endings. I think that the scheme that we've got handles line ending differences the way that we want. Whether you use, \r or rn kind of line endings. We're going to, start the new line at the appropriate position and refer to the same position, whether, you checked out on Unix or on Windows. And as far as committing source generated code, this is something that people often do intentionally. They want to be able to audit what changes are occurring to their generated code and understand exactly what that could mean and everything. And basically, if you're in a situation where you do not run the generator each time you hit build, it's going to be difficult to adopt this. And that could either be as a Roslyn source generator, where it's the extension loaded by the compiler, or it could be like an older kind of MS build task generator that that kind of stuff people have been using for a long time. They get used that have been used in the platform, like for ResX and everything like that. It's basically, if you have to manually run your generator as a separate step, then things could get problematic.
Okay.
Because things will get out of sync. You run the build again, but you didn't update the generated code. Things are out of sync, and you get build errors.
Mm-hmm. Okay. That was a lot of the last good questions we had at the moment. I scanned through to find some others. Is there anything else you really wanted to cover about the design, or where we're heading with this, or anything, Rikki?
I guess not a ton. There's certainly yes.
So I know a way we can use a couple of minutes. We can take advantage of a couple of minutes in a positive way, particularly if we have Jason here and maybe some other folks that are source generation folks is to talk just a little bit about some of the incremental generators stuff and some of what we're encountering there, because you and I have had a lot of really good conversations about just how difficult it is to write a good incremental generator today. And so if you like, we could spend a few minutes on that if we don't have more that we want to cover on interceptors and we don't have more questions on interceptors.
Sure. I might as well briefly point out that there's a proposal for this feature on C# Lang for interceptors.
Yeah.
It's fairly in-depth and detailed, and what we're actually doing in .NET 8 is a much more stripped down, experimental kind of compiler only type of thing that doesn't ripple the entire way through the tooling like we might have anticipated for a language feature. In fact, we're referring to this as a compiler feature at the moment, and rather than as a language feature, because it's solely being driven by a couple of attributes, and we sort of see it happening more on the instrumentation side. We almost compare it to like what a code coverage feature is doing. So hopefully that helps give a little context on how we're handling the feature. And yeah, I would love to talk about the challenges of incremental generators briefly.
Yeah. And before you do that, Rikki, could you grab the link, because you have this open? Could you just grab that link and maybe drop it into our Teams chat, or you could drop it into the chat?
Yeah, I'll drop it.
Bill's already got it. Okay, great. I just want to make sure we get that out to people so they can, think about this. And certainly, we do everything in the open, even our experiments. So please understand, there's no promise. We're going to do this. But yeah, so Rikki and I meet every other week to talk just about generators, make me smarter on them. And it's been interesting because I thought I understood them, and he's made me way smarter. Other people have been trying to do that too. I don't think I'm overly dense on this. I just think we do have something that's kind of complicated, and we're challenged by not having documentation. If that everybody's challenged on that, and right now that's been really hard for us to get that right, because there's plenty of nuances on it. So anyway, Rikki, where do you want to start? Do you want to start someplace on that? Or, we just have a couple minutes. We can maybe spend 5 minutes on this.
Yeah, I mean, I would encourage folks, looking at authoring incremental generators to start by seeing if their problem can be solved with some of our specialized APIs, like for attribute with metadata name. If you can identify that you need to do something by the presence of an attribute, that's going to be vastly preferable at this point to checking if something implements a certain interface, or if the, method has a certain signature and that kind of stuff.
Okay, so let's talk about why. Let's talk about why that is, because there's, so let's just say that we want to find out if something is a particular type, or we want to find all of our types in our project or something. We wind up, this whole thing about the syntax versus the declaration phase versus the binding phase was one of the things that was new to me. And so maybe a quick, why is Bill laughing?
Because I've had to be updating parts of the spec that deal with those parts, and it hurts. It's not the way we normally think about code, so it's definitely puts your mind in a different space.
All right. Okay.
Yeah, so my understanding is that when you use our specialized APIs, like for attribute with metadata name, we are able to more deeply leverage the incremental parts of compilation, right? And we're generally, when we're talking about tooling, we're thinking of scenarios where like user has a compilation, bunch of source files, bunch of references, and they're in a single document and they're typing, right? And we're really optimized for incremental edits that are like that, basically. What happens is the sort of further through the phases you get when you reach like the declaration symbol table creation kind of phase is that unlike syntax and so on, we reach a point where we can't incrementally reuse things, right? So if you are depending on certain APIs from an incremental generator, you may not actually get the kind of incrementality that you expect. this is basically because symbols can't be shared across compilation. Like the system.string in the first compilation before you type a key is not the same system.string as after you type the key. The my widget class that's present declared in source, it's not the same symbol as the one after you type a keystroke kind of thing. And this is really, really challenging. In order to look anything up, in order to like look an identifier and decide like what's this referring to, this could require creating boatloads of symbols, right? And doing a lot of declaration binding. And it's very, very challenging.
Yeah. So the just to help get this into code that people look at. Okay. So Rikki, if I touch the semantic model, okay, at all, I'm doing anything with semantic model, then I immediately get into at least the declaration phase, correct? And it's not, is it done across the entire model? So 2 questions, I'm sorry, on top of each other. So
I mean, basically it's difficult to answer definitively because laziness is really baked into the symbol model, but there are still plenty of places where we need to realize a lot of stuff in order to answer a question.
Okay, so if I just say get symbol, if I say get symbol, I have a piece of syntax I have a type, and I say get symbol. Does that spawn additional work, or is that something that can be done without additional work?
It will probably do a lot of work when you try to do a lookup, because it's going to basically go through the scope chain and look at like all of the namespaces that you're in and other declarations that you're in lexically, get the other members of those in order to provide the results to look up in each scope. And it's likely to go, all the way up into your usings and to sort of metadata references and realize symbols from those in order to figure out what you're referring to. And this is not done, I think 100% in a single shot necessarily, but there's a lot of places that we need to look in order to be sure what system.collections.generic.list means, right? Because anything can declare that.
Right. So it's extremely difficult to write a generator that doesn't do that. I can just tell you. I mean, I can't think of a single one I've looked at that did not need to touch the semantic model at some point. So the work that we are considering that probably be looking for more community feedback on is, can we offer more key things that can keep you from having to read it up to the semantic model? So the attribute one was the biggest one. We needed that internally. So that was a kind of a first step in this direction. And so just for, just to quickly, I guess, recap here is that, for a source generator, an incremental source generator, pushing everything that touches a reference to the beginning of your generation, because once you touch a reference, then everything incremental before that just kind of got wiped out. So because you need that. I'm saying reference. Let me rephrase this completely. That's completely wrong. I sometimes casually think about that, and that's just wrong. It's value equality is the point here. So as soon as you touch something that does not have value equality, which includes a reference, but is not limited to that. So something doesn't have that. Well, actually, a reference. If you're touching the reference itself, as opposed to the actual equality, value equality, we need value equality to do caching. Okay, so everything, you need everything that touches anything that does not have value equality, stuff to the beginning. You need to build a model that has value equality, and then you need to go from there. And even if you're just doing that right before the output step, if you can save the output step, you save the compiler work. And so trying to limit that as much as possible. And if your generator does like no work except find stuff and then barf some things out, it's still helpful to have a thing that is cacheable before you call your output so that you can limit, you not output when you don't need to. So
Yeah, and I wanted to comment on 2 things there. First is that, of course, symbols are very much related to what you're describing. If you put symbols as the output of a run step in an incremental generator, that's very problematic because they're never going to end up being equal for the reasons I've described. You want to dig into the symbol and get the strings and identifiers and values and whatever specific stuff that you need to decide if things have meaningfully changed, like the arguments to attributes and things like that, as sort of constant values. I think the other thing may have escaped my mind. We'll see if it comes back, but we might be out of time too.
We're getting close, so we'll give you just a second here. I talked about value quality. I talked about outputting too. Was it that triggered something?
Let me think. No, I think I'm not sure actually. I think it's flown to the wind.
Well, I think this is kind of like summarizing it, and I put the comment in chat. This is one of the things that Kathleen and I know we need to cover better. Is if you think about how a compilation works, classically in the abstract, right? As you talk about syntax, right? It's just, does this look like it could be C#, right? Does every token mean something valid? And at that point, valid just means, okay, if it was supposed to be an identifier, yeah, that's an identifier. And then you get to the semantic model where you start talking about, well, okay, what does it bind to? Is it a member in this class? Is it another name? Is it a method somewhere else from wherever? And now suddenly that is a lot of different work. Conceptually, you can think of them as two totally different phases of doing certain things. If you actually wanted to run fast, there's a lot of optimizations that happen, and how you deal with those models gets really important. I think is a lot of where this goes. It's like, yeah, this way will be fast. This way will be really slow.
Yeah, and this is almost like this is a great problem to have in a way, because the fact that we want to run generators, sort of on keystrokes, so to speak, it's something that we want in order to enable our high level of traceability and toolability and stuff. But it also means that it has to be keystroke speed, right? It's almost like we're writing a game or something. We've got 15 milliseconds to do this job. And that means that mistakes can really, really impact the dev experience badly.
Yeah. And with that, I think we've answered pretty much most of the questions in chat. We gave everybody a good, nice, healthy fear of incremental generators.
Let me throw in a couple more things. I'm sorry. I was on mute. Sorry. So one of which is, if you're writing generators, okay, and you're writing them for your own team, it's great because you know the size, and your tests are against the size that you're going to be working with. But generators become a problem as the number of lines of code in the project get bigger, because the longer it takes to build the semantic model, the more, or the syntax tree gets cached pretty well. So that's not as much of a problem. The longer that takes, if you're touching it, the more problem we have as the model. As the number of lines of code in your project get bigger. And so that is the biggest thing. And the other thing is, we are looking at backing off and doing it on every keystroke. So you might see some changes coming up where it is happening what we think will be often enough, but not on every keystroke, because we're having real problems with performance as there's more generators. So those are the things that we're thinking of. And if you haven't heard, iSource generator interface is being deprecated. So you should be using incremental source generators only. And with that, I will hand it back to Bill so he can close us out, because we are at time. And
with that, yes, we're at time. We had a great conversation. The spec and the issue are both in the chat. Tag Rikki Gibson on GitHub for continuing the conversation there. And I want to thank you. This was super, super interesting, really well thought out. And we will see you next month on the Runtime and Languages Stand-Up. And with that, thank you everyone for attending.
See you, folks.